Hello everyone, it's me Sanjay Vasu back again for another video. This time I'm doing it on Cambridge Primary Checkpoint for Mathematics Paper 2, October 2021. Let's start. Question 1. Here's part of a number line. Draw a line to join each mixed number to the correct place on the line. The first one's been done for you. 2.5 goes halfway between 2 and 3. 3 1/4, that'll be 3 plus a quarter, which is 1/4 of distance between 3 and 4. So it's over here. 1 3/4, that's 1 plus 3/4 of the distance between 1 and 2, so it's there. That's the answer. Question 2, here for a picture of buildings. Take the pictures that have a line of symmetry. This first one right here has a line of symmetry, which is the vertical line in the middle. The second one over here also has a line of symmetry, the one vertically in the middle. And then this one does not have a line of symmetry, cannot be cut in any way. And this one might look like it has, but then this square over here on top is a bit to the right of the middle line, so it doesn't have. Question 3. Eva says multiples of 3 always end in 3, 6, or 9. Is she correct? Yes or no? Give an example to explain your answer. Answer is no, because for example, 12 is 3 times 4, and that is a multiple of 3, right? And this does not end in 3, 6, or 9. So the answer is no. Question 4. Here's some statements about odd and even numbers. Join each statement to correct answer. The first one's been done for you. Odd plus odd, that's equal to an even number. For example, 3 plus 5 is equal to 8, or 5 plus 5 is equal to 10. Odd plus odd minus even, that's just this even over here minus an even, which will be an even number. Even minus odd plus even. So that's two even numbers added together, that'll be even, and then subtracting an odd to get odd. Even minus odd minus odd. So we subtract odd twice, we'll go back to even. Odd minus even minus even. Odd minus even is odd, and that odd number minus even is another odd. So that's that. You can use examples. For example, this one, 3 plus 5 minus 4 is equal to 4, even. 4 minus 3 plus 6, 7, odd number. Even minus odd, we can do 10 minus 3 minus 3, that's 4, even. Odd minus even, 11 minus 6 minus 4, that's 1, odd. That's the answer. Question 5, here's a page from the calendar. Chess Club meets on the third Saturday of every month. Write the date of the meeting in April. So the Saturdays are in the 6th column, and for April, we'll have 31st of March here. That means 1st April, 2nd April, 3rd April, 4th April, 5th April, 6th April over there. And then every 7 days, it becomes the same day. So 5th April is a Saturday, that means 12th Saturday, and 19th is also Saturday. This is the 3rd Saturday of April. And therefore, 19th April is the answer. Question 6. So Lily subtracts 56 from 92. She explains her method by writing. 92 minus 56 equals 92 minus 50 minus 6. Lily subtracts 298 from 406. Complete the explanation. 406 minus 298 is equal to 406 minus 300 dash dash. So 406 minus 300, that's equal to 406 minus 298, but then we subtract another 2. So to make it equal to 98 for these two, we have to add 2 to make it come back. And if we did the operation, this will be 108 over here, and this will be 106. So you have to add 2 to get 108. That's the answer. Question 7. Oliver says if I divide 85 apples between 5 people, they will get 18 each. Write a multiplication statement to show that Oliver is not correct. We need to write a multiplication statement so we can multiply these two and check if that's equal to that. Because 85 divided by 5 is equal to 17, that's not 18, right? But we can't write that because we need multiplication. So we bring that 85 by 5, we bring this 5 to the other side to multiply. And that would be 18 times 5 is equal to 90, which is not equal to 85. That's the answer. Question 8. Here are two rectangles drawn on the centimeter square grid. These two have the same perimeter. Draw a different rectangle on the grid that has the same perimeter. So these two are 2 by 5 rectangles. They're just oriented in a different way. And now we need to draw a completely different rectangle having the same perimeter. So these ones have 2 plus 5 plus 2 plus 5, which is 14 as their perimeter. So we need another which has 14. And that will be 3 plus 4, right? And actually there is one more answer to this. Just a minute, I'll draw this like a rectangle, yeah. There's one more answer to this, which is a 6 plus 1 rectangle. Now, if you count them and add up, there'll be 14. These ones also be 14. That's the answer. Question 9. A bag of money is placed on the scales. Estimate the mass of the bag of money. So this arrow is pointing in between 6 and 7 kilograms. So it has to be around 6.5 kilograms. Question 10. Calculate 9.5 times 3 plus 4. That's equal to 9.5 times 7, which is equal to 66.5. And now 9.5 times 3 plus 4. This time we do the multiplication first, because before we had to do brackets first. Now there's no brackets, so multiplication. 9.5 times 3 is equal to 28.5. We add 4 to get 32.5. That's the answer. Question 11. All children in the school either have school lunch or packed lunch. This bar line chart shows the number of children who have school or packed lunches in each year group. A. 20 children have school lunch and 32 have packed lunch in year 5. Complete the bar line chart. So 20 have school lunch, right? And that means we can draw a line, the 20, and just make that a bar like that, put it over here. And now for the packed lunch, it's 32. So you can bring that up a little to 32 right there. And that's our bar. Now, I'll shade the school lunch in black, and the packed lunch, I'll keep it in white, just so you can discern between the two. But in the exam, you're only allowed to use pencil. You cannot use black pen. Okay, you can use black pen, but then you can't use multicolored pens. So it's better if you shade it with a pencil, like that. And this one is where we shade lightly with a pencil, because it's black and gray. We need to make it same color. B. Write how many more children are in year 4 than year 3. So year 4 has 29, because it's in the middle of 30 and 28, and then plus 23. So we get 52. And then for year 3, we have 30 plus 20, which is 50. So year 4 has 52 minus 50, which is equal to 2 children more. Question 12. Draw an arrow to show negative 6 on the number line. So negative 6 is 6 units left of 0. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. It's over there. And we can draw an arrow like this. Question 13. Chen draws shape A on the grid of squares. He translates the shape to position B. Write instructions to describe the translation. So let's just take one of the points corresponding to the other shape and see how the point is moved. In the x plane, or in the horizontal plane, is moved 1, 2, 3 left. 3 units left. And that means it's a minus 3 in the x value. And then 2 units down. And that means it's minus 2 in the y value. So it's a translation to vector minus 3, minus 2. Because the minus 3 x coordinate has to come on top and minus 2 has to come on the bottom. Question 14. Here's 6 digit cards. 2, 3, 4, 5, 6, 8. Use each card once to complete these statements. So 1 by dash equals dash by 8. So there are two different answers. There's 1 by 2 equals 4 by 8, or 1 by 4 equals 2 by 8. Now I'll go to the second part. Dash by 4 equals 6 by dash. There's only one answer to this. 3 by 4 is equal to 6 by 8. And now the remaining numbers are 5 and 6. 3 by dash is equal to dash by 10. Over here, there's two answers. 3 by 5 equals 6 by 10 is correct, and 3 by 6 equals 5 by 10 is also correct. So anything is fine. Oh yeah, by the way, this one, if you switch it also, 8 by 4 equals 6 by 3, that's also correct. Both equal 2. So at the end, actually, it doesn't matter where you place these two. They have to be 4 and 2 somewhere in these two. And these two, it can be 3 and 8 in any order. These two has to be 6 and 5 in any order. And that's the answer. Now you can go to question 15. The symbols circle, square, and triangle each represent a different single-digit number. Circle times triangle is 36. Square over 2 is circle. Write the value of each symbol. First of all, we need to realize that all of these values are single-digit numbers. The only way to make 36 from two single-digit values is 4 times 9. So 4 times 9. I'll tell you why circle has to be 4 and triangle has to be 9 in just a minute. So circle is 4. Something by 2 is equal to 4. That something is a square. So square has to be 8. And why is circle 4 and not 9? Because if circle was 9, square would have to be 18. And that's not 1 digit. That's 2 digits. But we need single digit numbers, so we got that. So 4, 8, 9. That's the answer. Oh yeah, by the way, if you're wondering if we could write 6 times 6 is 36, that's wrong because different single digit number. So duplicates are not allowed. That's the answer. Question 16. 3 identical isosceles triangles are arranged to make a new shape. Calculate the size of angle A. So these are isosceles triangles, so these two angles are equal. 70, 70, and this is also 70. These are 70 because it's isosceles, identical isosceles triangles. And this is a straight line, so 180 degrees. A is equal to 180 minus 70 minus 70, right? And that would be 40 degrees. Question 17. Complete a diagram to show fractions equivalent to 3 by 5. 3 by 5 can be written as 6 by 10, 12 by 20, 60 by 100, 27 by 45, and 9 by 15. If you wonder why, just simplify these fractions and they will all come down to 3 by 5. That's the answer. By the way, if you still didn't understand why we are having these values for each of the fractions, let's just take one example, 6 by 10. So let's just say we do not know this, right? At the start of the question, we do not know, so let's just say that's x. 6 by x is equal to 3 over 5. That's what we need. And now bring the 5 over here. That means 30 over x. 30 is 6 times 5. So 30 over x is equal to 3. And x is equal to, bring x here, and then bring 3 here. So 30 over 3, which is 10. And that's what we got. And using a similar method, we can find out all the other x's over here. That's the answer. Question 18. Here's a bar line chart. It shows the scores of some students in a maths test. The frequency and score is given. Write the modal score. That means it's the highest frequency, and the score with that frequency is the modal score. So the highest frequency is 11, and that score is 7. So the score, modal score, 7. Write the range of scores for this test. So the range is simply 10 minus 1, because 10 is the highest and 1 is the lowest. That's 9. Notice that no people got a 0 out of 10, right? None of them got 0 out of 10. If someone got 0 out of 10, the range would be 10 minus 0, which is 10. But then, since no one got that, it starts from 1, so we have 10 minus 1. 1 is the lowest, so that's 9. Question 19. Match each fraction to an equivalent decimal. The first has been done for you. 1 by 2, 0.5. 3 by 5. That's simply equal to 6 by 10, which is 0.6. Now 3 by 4. That's equal to 75 by 100 if you multiply by 25 on both sides. And that would be 0.75. 30 by 100, simply 3 by 10, which is 0.3. And 3 by 10, once again, 0.3. 0.03 is not taken because there's none of these equivalent 0.03. Question 20. 2 identical square-based pyramids are joined to make a new shape. Complete the table for the new shape. Number of faces. So we have 1, 2, 3, 4 on this top pyramid and 1, 2, 3, 4 on the bottom pyramid. Since they're square-based, they have 4 each. Therefore, it's 4 times 2, 8. Number of edges. We have 1, 2, 3, 4, 5, 6, 7, 8 for the square, and another 4 for the triangle edges. So that's 4 plus 4 plus 4, 12. Now the number of vertices, that is 1, 2, 3, 4, 5, 6. There's only 6 vertices. That's the answer. Question 21. Rajiv has $25. He buys a magazine for $6.99. He also buys 2 cinema tickets costing $8.50 each. How much more money does he need to buy an ice cream costing $2.99? You must show you're working. So he's buying 2 cinema tickets costing $8.50 each. That'd be 2 times $8.50. And then we add the cost of the magazine. And that will be, if we did it correctly, $23.99. Now, he wants to get ice cream costing this much. So, right now he has $25. Spending $23.99, he will get $1.01 in return, or $1.01. And he needs some amount of money to get this $2.99 ice cream. So we'll just subtract 2.99, 1.01 to get $1.98. And that is our answer, $1.98. Question 22, here's a grid of numbers, drawing around the 2 prime numbers. These are simply 23 and 29 because they only have factors of 1 and the number itself. That's the answer. Question 23. Here's part of a sequence. It continues in the same way. A, write the first number in the sequence that's greater than 1000. By the way, if you're wondering why these blanks are given, these are just given because there's nothing given before, but then the sequence is continuing in the same way before and after these numbers. So first number that's greater than 1000. Every time we are adding 30 to a number to get the next number in the sequence. So we continue on, we need to add 30 a few more times. To be exact, 26 more times. So we add 26 times 30, that would be adding 780. And 230 plus 780 is 1010. That's the first one greater than 1000 because if we had 25 times 30, that'll be 980. And that is a bit less than 1000. So 1010 is the first one greater than 1000. B, write the negative number in the sequence that's closest to 0. This means the last negative number in the sequence. So we subtract 6 times 30, which is simply subtracting 180. We will get negative 10. And that is the value closest to 0 because the one right after that is 20 and that's positive. But then this is negative and that's close to 0 since the rest will go negative 40, negative 70, they go further. That's the answer. Question 24. Here are 6 measurements written on cards. Write the letters A, B, C, D, E, and F to make pairs of equal length measurements. 3.481 kilometers. So first let's convert all of these to meters. So this is 3481 meters. And then this is 0.3481 meters. This is already in meters. This is already in meters for C and D. E is 0.3481 meters. And F is 34.81 meters. And now we can match A and D, B and E, and C and F. That's the answer. Question 25. Here's a thermometer. The difference in temperature between Moscow and Durban is 27 degrees. Write the temperature in Moscow. So difference over here is 27 degrees. So if we have a scale of 1 unit is 2 degrees Celsius, only then the difference over here is 27 degrees Celsius. Since this is in the middle of these two, so that'll be 1 degree and then 3, 5, 7, 9. It goes on till 27 if you count it. So we will have the temperature in Durban to be 2 times 8 gaps, which is 16 degrees Celsius, and the temperature in Moscow to be -2 times 5.5 gaps, which is minus 11 degrees. And why -2? Because we're going down below 0 on the scale. So -11 degrees is the temperature in Moscow. Question 26. Calculate the area of this classroom. Show you're working. So we have this side length of the small rectangle which has been chipped out from this larger rectangle. Now we need to find this side length. Only then we can find the area of this and subtract from this. Therefore, we can do 4.5 minus 3.3 to get this, which is 1.2 meters. Now, we can do the area of the big rectangle, 4.5 times 6.5, minus the area of the small rectangle, 1.2 times 1.8. Once again, the rectangle with the small rectangle is over here, the big one is over here. The small rectangle has been cut out. That's why we're subtracting. Now, we can get a calculator out. There we go. So 4.5 times 6.5 is equal to 29.25 minus 1.2 times 1.8 is equal to 2.16. And if we subtract correctly, we will get 27.09 meters squared. That's the answer. Now we can go to question 27. Yuri has some digit cards from 2 to 7. He puts them in a number triangle. Each side of the triangle is a 3-digit number. Complete Yuri's triangle. A 3-digit number that is a multiple of 25. That means I have these numbers. It can end in either 7-5 or 2-5. So the last digit has to be 5. That's over here. So let's just say that this digit is 2, assuming. Now, the other digit can be any value. Now, this one has to be a 3-digit number multiple of 4 greater than 500, which means this digit has to be 6 or 7. So let's just say it's 6. And now is a 3-digit number a multiple of 4. Therefore, it has to end in the last number 4, which is an even number. Only if it's even, it can be a multiple of 4. But then what do we put here? There's 7 and 3, but then these one make it a multiple of 4. That clearly means we have to change. So let's just say that this is 7. And now we have 2 over here, and this makes it a multiple of 4. But then we need to check the last number, a 3-digit number that's a multiple of 5 between 200 and 300. This is not in between 200 and 300. The first digit is 4, that means it's greater than 300. Now let's just say we swap these two. Now we got this correct, but then the multiple of 4 is wrong. That means we need another change, right? This one has to be 2 because it was 300, then it'll be greater, right? So this has to be 2. This has to be 5, we know that. So what's the last number remaining? That's 3, right? So you can put 3 here instead of 4. And of course, it's only 6 or 7 here, so we have to put 7 here and 6 here. And the last number remaining is 4. And now let's check if we got our conditions correct. There's a multiple of 25, correct. That's because 25 times 27 is equal to 675. Now, a 3-digit number multiple of 4 greater than 500. This is greater than 500, and it is a multiple of 4, since 158 times 4 is equal to 632. Next, this is a multiple of 5 between 200 and 300. This is correct, and multiple of 5, yes, because it ends in a 5. And if you want proof, 49 times 5 is equal to 245. You can use a calculator and check that out. That's the answer. Question 28. Here's a spinner with 6 equal sections. The likelihood of spinning a 1 is even. Spinning a 2 is impossible. Spinning a 3 is unlikely. Spinning a 4 is also unlikely. Complete the spinner such that each section is numbered 1, 2, 3, or 4. So 2 is impossible. We know that there are no 2's there. 1 is even. That means it's a 50-50 chance. I have 6 sections. Which one gives a half chance or a half probability of spinning a 1? We need 3 ones. Therefore, we can write 1 on 3 different spaces. Now there's 3 more spaces which we need to fill with 3's and 4's. Both are unlikely. Therefore, we can put any number of 3's and 4's as long as there's at least 1. So you can put 2 3's and 1 4, or you can put 2 4's and 1 3. By the way, it doesn't matter where you position it. It just has to be having the same number of digits, like this. Now, Anastasia is asked to make a different spinner so that spinning a 9 is certain. Complete Anastasia's spinner. So spinning a 9 is certain. That means probability is 1. So it must happen. And that means there are 9's on every single section. And that would be our answer. With that, I come to the end of the paper. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.